Thank you. It's a great pleasure to welcome Chiara Visentin, who's a senior researcher with URAC Research and has done a lot of research with University of Ferrara. And you're now going to take us in to occupied classroom scenarios and see the difference it makes with classroom chatter, group work, and the workload for students, and how they're affected motivationally and with their learning outcomes as well. Thank you.
Thank you.
Yeah.
Thank you very much. Good afternoon to everyone, and thanks for the introduction, and thanks for inviting me to EIAS. My name is Chiara Visentin, and I work in Italy. And today I'm going to talk about classroom acoustics. And I will present the results of a study that was conducted last year, and it was a multidisciplinary study. It was a collaboration between experts in acoustics, linguistics, and psychology. So, classroom acoustics. We all know that it's crucial for students who spend several hours per day in schools, and during these hours they learn new knowledge, they acquire new skills, and they also develop their social and emotional skills. The aspect of the school climate that interests us the most is the sound environment. Not only because we are all acousticians here, but because if we ask directly to the students, they consistently report that the aspect of the environment, the indoor environmental quality that bothers them the most when in their classrooms is the background noise. So what happens when we have background noise in the classroom? The first outcome is a drop in speech intelligibility. And the amount of the drop depends on the noise level, of course, but also on the spectrotemporal features of that noise. So when we directly compare the effect of different types of noise presented at the same level, and in the figure you can see the comparison between traffic noise and classroom noise, we see that the noise produced by the children themselves, so voices, movement, is the most detrimental to speech perception. And not only to speech perception, also for more complex tasks, because children in the classrooms are not only required to correctly perceive the words that the teacher is saying, but they also need to elaborate on them, to memorize them. So they are doing complex tasks, listening comprehension, reading comprehension, math, and so on and so forth. Another dimension that we really need to address when we talk about classroom acoustics is listening effort. Listening effort is defined as the amount of cognitive resources that a listener allocates when carrying out a listening task. Listening effort is like a quite new concept. It derives from the field of audiology, but it's increasingly being used in other research fields. So why listening effort is so important for classroom acoustics? Let's make an example. A couple of years ago, after the first lockdown, the pandemic, I set myself a challenge, and I decided that I would have run for 10 kilometers in less than 35 minutes. Maybe it's not a big deal, but I've never run before in my life. And I soon discovered that I was able to run for 10 kilometers. But depending on the amount of training, I could arrive at the end either fresh as daisy, like professional runner style, or Homer style. So, the distance covered is exactly the same, 10 kilometers, but the way I arrived at the end was completely different. And when we talk about listening effort, we are saying the same thing. The accuracy in speech intelligibility, the mark in the math test could be the same, but the amount of cognitive resources that the children need to allocate can be hugely different. Effort is based on two aspects that interact together. The first one is the cognitive demands, so the challenges of the listening task that could be acoustical, for instance, a too long reverberation time, or they can be related to the listener, for instance, the language ability. Imagine someone learning in a second language. The second aspect is motivation. And in a listening task, motivation is related to how well perceptual and cognitive abilities are used to understand what is being said. So once again, motivation is crucial for students in noisy classrooms, because if they are motivated, they will continue listening to the teacher without disengaging or withdrawing from the lesson. The last aspect I want to introduce briefly is maybe an obvious one, but it should be stressed. So the effects of sound on human performance are mediated by individual competencies. So here in the figure, you see the results of a survey. So we asked students to rate the effort in a listening test, changing the listening conditions. And what is important is the huge inter-individual differences. So we have a huge variation in the responses that the students gave us. And I'm not talking about students with special educational needs. They were so-called children with a normotypical development. So, and this was an acoustically treated classroom. So it means that even after a correct acoustic design of the classroom, there may be some normotypical students who won't be in the best conditions to learn. So we set up a study with primary school children, and we presented them a sentence comprehension task, and we wanted to understand how individual competencies interact with the effects of the listening conditions in determining the effects on accuracy, listening effort, and motivation. The study was conducted with more than 100 primary school children, and we used a highly ecological paradigm so that the children performed the experiment in their classrooms together with their classmates. It was not easy. It was also the period of the pandemic, so it was not easy at all. We used a comprehension task, so something more than a speech intelligibility task. The children heard through headphones a sentence, so the child chases the dog and the cat, and they had to select the image on the tablet that best matched the sentence content. Listening conditions, we obtained them by auralization. So we set up the virtual model of a classroom. The classroom complied with the requirement of the Italian standards on classroom acoustics. There was like a virtual teacher speaking at the desk and a student, a virtual listener in the center of the audience area. And the background noise was a two-talker noise. So two other children talking at the left and the right of the listener. And we manipulated the signal-to-noise ratio. So we had two conditions, +1 and +9 dB. So an hard and an easy listening condition. And for each condition, we recorded the accuracy, we recorded the response time, and we also asked the children to rate the effort in doing the task and their motivation. And we also did some testing to investigate linguistic skills, cognitive skills, and individual trait of the children in quiet. Linguistic skills, we presented them with a reading comprehension task to assess the reading comprehension. Individual trait, we asked them to self-report on their noise sensitivity. And cognitive skills, we selected one of the executive functions, so the inhibitory control of attention, which is the cognitive function that allows us to focus on a single speech stream, disregarding, without putting our attention on other distractors, so other people talking, someone moving, and so on and so forth. So the results, accuracy. As expected, children had a higher proportion of correct responses in the easy listening condition compared to the hard listening condition. That's what we were expecting. And response time, so yeah, I forgot to say that we included the response time as a measure in the experiment, because response time is a behavioral measure of listening effort. So the idea is longer response time, greater amount of cognitive resources allocated, increased effort. And what we found was a significant interaction between the listening condition and the cognitive skills, so inhibition. Meaning that only children with better inhibitory control experienced an increase in effort when changing from easy to hard listening condition. Also, in perceived effort, we observed a significant interaction between an individual factor, so noise sensitivity, and listening condition. And this time we saw that only children with high noise sensitivity perceived more effort in the hard compared to the easy listening condition. Last, motivation. Also for motivation, we observed this kind of interaction. This time, listening condition interacted with reading comprehension. And only children with high literacy skill, with high reading comprehension, benefit from a better listening environment, meaning that they rated to be more motivated to learn, to completing the task in the easy than in the hard condition. So, to conclude, we set up to investigate whether for children with normotypical development, there was an interaction between individual competencies and listening conditions. We found this interaction not for accuracy, but on a more cognitive dimension, so the dimensions of listening effort and the dimension of motivation. I just want to stress that if you are a teacher in a classroom, you know very well how to motivate students. So in the psychological, pedagogical domains, they know very well how to deal with motivation. But in room acoustics, it's an under-researched area. So there's like a word to discover on what motivates students to learn in noisy classrooms. Why bothering investigating individual, this interaction between individual competencies and listening conditions? Because that could explain why some children are more vulnerable than others, and to understand what are the best ways to alleviate these difficulties. For instance, is this enough to acoustically treat the room? Or should we also work with teachers, raising awareness of teachers and students on their role in creating noise in the classroom? So the overall goal is to develop a student-centered approach to the issue of acoustic design of classrooms in order to obtain, to design inclusive and supportive environment for all the students that learn in that classroom. Okay, that was the end. That's the conclusion of my presentation. Thanks for the attention.